Hi. Well, it looks like I don't have any takers on today's video conference, but I'll go ahead and do a quick video anyway, and we'll see what normally would be covered. Chapter 9 is about pointers and dynamic arrays. Pointers, you may remember from the first semester C++ are memory addresses of variables, and we declare a pointer by declaring them the same way as variables of the type that we're pointing to, except by including an asterisk at the beginning of the variable name. And that indicates that it's a pointer. If you look in your book on page 498, there's a diagram of some code there that shows you how pointers can be allocated and reused. You should be familiar with the new operator that allows you to create dynamic memory, dynamic variables that you can then point to with a pointer variable. If you do allocate memory that way, it is taken from the free store or heap, and once you're through with it, you need to get rid of it by using the delete operator. If you have two pointers pointing to the same piece of dynamic memory and you use the delete operator on one of them, the other pointer is what's called a dangling pointer, meaning that it's pointing to memory that's no longer allocated, and that can cause problems. We call variables created with the new operator dynamic variables, as I mentioned. Ordinary variables that are not created with the new operator are allocated automatically for us. We've also mentioned previously global variables, but we have also recommended that you do not use them. Section 9.2 shows you how to create dynamic arrays, and there's a sample program. When you create dynamic arrays, the memory allocation routine remembers how many elements you had in your array, and when you do a delete, you delete with the syntax delete open bracket, close bracket, variable name, and that causes the variable of interest to be, or the array of interest to be deleted. Delete open bracket, close bracket A. That would work for whatever kind of array we made. And we could do whatever we wanted to with that array, and then when we were through with it, we would delete it with that delete bracket syntax. Okay. The last section is about multi-dimensional dynamic arrays, and that is especially significant because our homework assignment is creating a multidimensional dynamic array in order to redo a problem from a previous chapter. Let's take a look at the assignment. So if we go to the content section, assignment 2, chapter 9, number 3, that's on page 520. So project 11 in chapter 7 was the airplane seating chart, and I have included in the assignment some sample code that I wrote during a previous class, and we can just copy that into Visual Studio as a starting point. So here we have a type def for a character pointer char array pointer that's going to allow us to point to an array, a dynamic array of characters, and that's what I've set up for my seating chart array. If you used a different type of array, that's fine. And then here in the code, I have declared a new variable of type char array pointer called seating chart, and I've created a new array of character pointers for the number of rows, and then for each row I create another array of characters. So character pointers, characters, and that is of size seats. So basically what that's doing is creating a little array of the number of seats across. For example, if we had an airplane that has 33 rows and 9 seats across, then we first would have created the 33 rows of of pointers to arrays of characters, and then for each row 0 through 32, we would create another array of 9 characters that first array points to, and each of those 9 characters will hold the status for a particular seat. Alright, I then call the initialize seating chart function. Let's take a look at that real quick. In the initialize seating chart function, we loop through all the rows, and for each row we loop through all the seats, and we set the character for that particular seat and row to the seat number 0 through whatever. So if we had 9, that would be 0 through 8. That number plus the character A. So for 8, for example, that would be A plus 8. So A plus 8 would be B, C, D, E, F, G, H, I. And so we're lettering those seats A through I for each row. Okay. Following that, we have a display seating chart, which is going to display all of the seats that we already, or that we just got through initializing. Okay, so once again we loop through the rows, and this time we're going to output the number of the row plus 1 since it's 0 relative. So in our example that would give us 1 through 33 instead of 0 through 32. And then we loop through all the seats for that particular row. And what I've done here is I've said if seat modulus 2 equals 0, in other words, if 2 goes evenly into the seats, or the seat is an even numbered seat, then we're going to output a space. So we'll put 2 seats together and then a space indicating an aisle. This is a very unsophisticated aisle printing process. If we got more sophisticated, then we would probably want to make sure that seats of up to 6 across would only have 1 aisle, and it would be evenly divided, or as evenly as possible divided. If we have more than 6, then we would put in 2 aisles and try to evenly divide the seats among 2 aisles. So for our 9 seats across, that would mean we would have a set of 3, and then an aisle, a set of 3, and then an aisle, a set of 3. And we're just outputting the letter that we previously stored for that row. Now, and here's the part that I didn't do, we would do the part where we input seats. And so we would accept from the user a number and a letter indicating a seat. So for example, 31C would represent the 31st row, or row 30. C would be the 3rd seat over, or index number 2. So we have to convert from a row and seat to an index into our table. And so in this case we would say row would be equal to my row minus 1. Obviously we would need to put in some error checking if row is less than 0 or row is greater than rows, which is what our user input up here earlier. And in fact, we want that greater than or equal to because we have already subtracted 1 to make it 0 relative. So our maximum index should be 32. If the user has indicated 33, it's now 32. And so we subtract 1 from rows, or rows itself is too large at this point. So if that happened, then we would want to indicate an error. Then seat would be my seat, let's just say for to lower my seat. That will give us the integer equivalent to the character ASCII value for whatever letter the user entered. In this case it would be A. Actually I said C before, so let's say C. And then subtract the ASCII value for A. So we get seat as a 0 relative value. And again, if seat is less than 0 or seat is greater than or equal to seats, then that would be an error. Okay, and so the rest of the assignment would be to use that then to assign the seat. And the seat that we're assigning would be seating chart, row, seat. And as an example, I just put an X in there. Obviously that would mean that your seats, your number of seats couldn't go as high as X, the value for X. So that would be another constraint you would put on your code. If that value was already X, then that would indicate that seat has already been assigned. Otherwise, you could assign it and then redisplay your seating chart, and you would want to put the whole seat assignment in a loop so that you could keep assigning seats. And we would want to stop assigning seats when they've all been assigned. We could do that by multiplying rows by seats, figuring out how many seats there are every time we assign a seat, subtract 1 from that value. Something that would execute a little more code but would also work would be to check every seat after you assign the new seat to it and see if there are any still available. If you run out of seats, quit. If the user tells you they're ready to quit by either a sentinel value or a separate question, then you would also quit. And once you've done that, then you would need to deallocate your entire seating chart, your dynamic arrays that you made before, as demonstrated in the book under the two-dimensional dynamic array example. You would call delete for each row of seats, and then you would call delete for the array of rows, and then you'd be done. Okay? Now, if you have any question, contact me, and since we didn't get any participants today, I'm not sure when we'll want or if we'll want to have another online video conference, but I will go ahead and put a put a discussion topic up and see if anybody wants to have another video conference and when would be an appropriate time for that. Otherwise, I guess I will be communicating with you by email. You'll be putting stuff in the Dropbox, and I will look forward to talking to you in the future. Alright, I guess that's it for this week. Again, contact me either at barry.thurman@okstate.edu or barry.thurman@gmail.com, and I will try to answer any of your questions, look for assignments and other communication on the online classroom. All right.